I'm back, and as you can see, I'm disassembling LED globes, and this is a Frankenstein creation that I've come up with to fit a MIDI Edison screw. But ignore that for the moment. This is just a really quick video to demonstrate how I test these LED globes. Now I have two prongs here. These are connected to a continuity output that I designed myself. Now I'm using a reversing beeper and an LM7809 linear regulator. And the beeper is, I think, an LED and a resistor setup. So I've got about 400 ohms across that beeper, so it limits the current. But crucially, when I have these little units here, I can put a probe across here, I get a beep and I get working LEDs. Whereas this little one with a tiny little black spot here doesn't work. So I can tell that the series string on these has all been broken by two of the LEDs. But it's a good little one. This is one I'm doing in answer to a question from Tinkerman Mick. I think this one here is one he actually replaced. It's a smidgen wonky, but nothing too terrible. But I think one of the ones he put on is also blown as well. But let's just rotate around here to what I think is a good string, and we'll test all of these. And we'll see here. And we'll see here, yep. And these are obviously in pairs. So, yeah, they're obviously, yep. And these are all in a series string. Every single one of them, I think, are in parallel pairs in a series string across the whole unit. Well, that one didn't work. Or that one. I think I've got a few that have gone in here. This whole string here seems to be... Ah, wait. They're LEDs. They are polarized. Let's check the other way around. No, that no longer appears to be the case. We do have a positive and a negative end, so let's find a string we know is good. We might be able to test the whole string. So that one is good. So that is negative and that is positive. So let's swap around here. Let's touch each end of this whole string. See, I do have enough just to dimly test that whole string. And that's another quick way you can do that. If you were to up the voltage slightly, you'd be right. See, so that string there is not working. I've got a few blown strings, which probably means I'm going to gut this and use it. So this string is working with the exception of one that is not. We'll switch over to the microscope in a minute and just have a look at some of these blown ones under the microscope. Let's try that. Yeah, I've got a couple of strings that are completely gone. So this one here and this one here has a big black mark in it. Let's have a look at a good one and a bad one under the microscope and see what they look like. Okay, so here's normally where I have a problem synchronizing audio and video. So I'm going to do myself a quick little 3, 2, 1 here so that I can do that. So we're going a 3, 2, 1, start. Okay. Sorry about that. Normally I do all that sort of stuff post-edit. And yes, my apprentice is helping. You'll see on the screen here, now these are needlepoint probes over here. Where's my screen here? These are needlepoint probes that you probably can't see because they're out of focus. I'm going to put one in front of the microscope here and show you the tip. So these are very, very sharp tip points. Now, right along here, just be quiet a little minute, apprentice, I'm explaining stuff.
Dad, it's not sharp.
I know. It doesn't look sharp in the microscope.
The battery, it's not. The points are
Ah, my battery's going flat. Okay, we can see here this is a little leader wire that goes over to the LED.
Sharp.
This is the actual junction area, and the other leader wire is running off to the side here. Clearly this diode has self-destructed.
I have an idea.
My apprentice has an idea apparently. This is a good LED. Let's see if we can get some good focus on this one.
We can leave some
And so now we can see the silicon junction in here. It's buried under it, but this is the silicon junction right here. Ah, we have a new donation to open as well, which is some LED globes. We might incorporate that in a minute. However, my apprentice is currently getting dry by the heater. So, we now have seen a good LED and a bad LED. Let's move along and have a look at the factory solder job on this. So that's the factory solder job. Let's have a look along to Tinkerman Mick's handiwork. This one along here is one that Tinkerman Mick installed for me. And actually, I appreciate the hand soldered job here. It actually looks somewhat better. I quite appreciate that. Let's have a look at this end here. So actually, I'm pretty happy with his work, to be honest. Yeah. So, all right. Let's move on to some industrial LED globes and have a look at them. My apprentice is really excited about it, so let's open this bag of LED globes and see what's in them. Okay, so my apprentice has been nagging me to trial out these LED globes, and these came from cheap as chips for $8. Supposedly 10 watts and 810 lumens. Well, I don't have a light meter, however my photographer mother probably does. So we might go and try one of those to see if we can get some kind of an idea of our light output. And the 10 watts part...
The screen is pop.
Ah, yes, my apprentice found some party poppers and has been experimenting with them. So yes, we'll test the 10 watts part of this as well. This quick video is not quite turning into such a quick video. I do believe an associate of mine, Tinkerman Mick, you'll probably find him endorsed on my channel homepage. I do believe he's used a few of these and dismantled some, so we might consult him for one that's already open rather than tearing these down, because they might actually function rather well. But I think let's just plug one in and see what happens. These are 240 volt bayonet cap types for Australian use. I believe they're BC22, 22mm bayonet cap, or B22. And there's some information on the side there, so let's crack these open and see what's in them. So we're having some LED fun. So these are 10 watt, 3000 Kelvin, 810 lumen, 85 milliamps. Made in China. Well, where else would it be made, I guess? And Lightworks brand. My apprentice has run off to go and put one into a bayonet cap fitting. Why don't we go and see how she's doing? I have a bayonet cap fitting and it's a bit dark for obvious reasons. And I don't need a ladder because I'm 6'6". So let's go and turn on our light switch. Here you go, apprentice, you can turn on the lights.
Yay!
Well, that is unwholesomely bright.
Uh-oh.
I wonder if the 810 lumens is actually not a false claim. But it might be drawing more than 10 watts, so I'm used to Chinese globes being understated. And we can see here my camera's trying hard to auto adjust the white balance profile to compensate, but it is a nice warm light. It's not one of the bluish white ones that you normally see, so that's not a bad temperature. But yeah, let's do a few more tests. You'll have to excuse some of the background noises here. My apprentice is kind of enthused about the new light globes. Now, one thing I found is that these globes often work with a forward bias voltage much lower than the rated voltage of, say, 240 volts in this case. Let's turn off my fan-cooled power shunt in the background there. So I find quite often these things will stay lit if you have any kind of induction, like parallel cables and stuff in the roof. You'll get a little bit of inductive current that will light these up. So I find often we can power these through 12 volts and the likes and see how they go. So we might meet the forward bias of the LEDs, or just barely, if we fire it with 12 volts. So let's move our little needle probes up to our 12 volt input.
Dad,
What's up, apprentice?
it's dark.
Ah, my apprentice has found my mag light, my big 4D cell one, and is comparing that with LEDs. So yeah, let's see if we can power this from 12 volts. Okay, we're not meeting forward bias on 12 volts. I might need to move it up a little bit. But I am seeing an increase in current of about 100 milliamps through here. So 100 milliamps at 12 volts. It's not quite 10 watts because, and it's probably not because they're lighting up as well. And LEDs have this weird quirk where they change their behavior very drastically considering, or in relation to the voltage they're being powered from. So I may actually need to procure my, or reclaim my mains voltage current meter from Tinkerman Mick, because he's got it on loan at the moment to figure out some power issues in his house. I do have a clamp meter and a few other things. We could probably do it that way. Let me have a think, and we'll be back. Right, well, I'm back from Tinkerman Mick's house. And apologise if you can hear some bass beats in the background, but it's the weekend here and it's busy. So, I wanted to find a few things to test this globe. One of the things I retrieved was a donation I got a while ago, my little Belkin power meter tester. Now, I could do this with a set of clamps and all that sort of stuff, but this is much more convenient. Now, the biggest issue I've got is I don't have a light socket, so finding a way to safely connect this to mains to test it is a little tricky and a little unsafe. So at this point, I'm going to put a big bit of text down here going, don't try this at home. It's dangerous. Yes, I'm serious. Okay? So now we've said that, I have found in amongst my box of bits a lamp cord here, which has some 2-core flex coming out of it, and a 3-pin plug on the end. So that is straight away a massive no-no. So somebody with me with my test and tag certificate probably shouldn't have this in my collection. So now we can't do something unsafe. Not with that lead anyway. Or can we? This is where it gets dangerous. I'm making up what is commonly called in the industry as death leads. And I should probably use a proper sheath cutter to do that. I'm going to expose the copper on both the active and the neutral lead. Actually, it's active and neutral. Red and black, black and blue, which are the neutral, and red and brown. The two different color standards, red and black and blue and brown. And black and blue is what you'll be if you get that wrong. So, these are called death leads for obvious reasons. They can kill you. I'm serious about this. Don't bloody do this, okay? You've been told. It's not my responsibility now. So, I am going to, however, think about safety here. I've been to notify somebody else of what I'm doing in case there's a mistake. They can call emergency services. I have connected an RCD in line and tested the RCD to be sure that it works. The main supply that I'm using also has a tested and functioning RCD on the main board. So there are 2 residual current leakage detection devices in line. Chances that I'm going to die doing this are limited. However, I need to engineer a way to make sure that I don't touch any of this like this, because that will be bad. So, I'm going to probably tape this on and tape these on because I don't want to solder to these pads. I'll probably melt them out. So I'll use proper rated insulation tape to hold these down for the few seconds in which I'll be testing its current drain. Remember guys, in the words of Mythbusters, we're doing this so you don't have to. I've just had some visitors arrive, so I need to make this quick. Now, both my hands are well out of the way. Lots of ugly tape, very temporary. I'm going to cut them off when I'm done. Now, I'm well out of the way. There's an RCD involved. I'm going to flick the switch. Okay. So, we're pulling half a watt. Now, let's see if I can go. That's the dollars setting. Let's see if we can see how much power we're pulling. 9.7 watts. Or I think we can probably see that we're a little bit close. I wonder if I can get the exposure to dull down. Here we go. There we can see 9.7 watts. So the stated rating is fairly close. Let's turn this off and unplug our death leads. Alright, let's come back to this in a moment. The dangerous stuff and scary stuff's done. I'm going to snip these off just to avoid any sort of major accidents here. And I've got some new visits. That's probably some donations coming in. We'll check that out and be right back. Alright, so these Lightworks brand LED globes seem to stack up to their ratings. I wasn't lucky enough to get hold of a light meter, but yeah, they do seem to be pulling the right kind of wattage. I guess we'll have to wait till one blows up before I crack it open and see exactly how they're built. My bet is there's probably a capacitive dropper in there, as I haven't been able to get any reliable continuity across them. So yeah, there's probably a big series string of LEDs in here, probably SMDs. There doesn't seem to be anything under the surface here. This has turned into more of a breakdown and a review of a globe rather than a quickie. This is how you test SMD LEDs. But if I can find a light, maybe I can shine it through the back and we can get a silhouette of what's in there. So I've got a big 4D cell mag light here. Let's see if we can shine anything through here. I know that diffuser is well and truly opaque, hiding the master secrets of this globe. But there's certainly no structure above the level of the diffuser. So I'd say there's probably a nice little flat pancake somewhere about here, level in there. But nonetheless, well, these are actually good LEDs. Another safety violation of Frankenstein creation. Don't do this, guys. Just don't. This was an act of desperation to see if it would function. I'm going to go and buy some actual mini bayonet globes to do this. But yeah, it did work to get me out of trouble. And this was in a double insulated light fitting, so the chances that prying hands of untrained individuals were unlikely or highly unlikely to come across it. But that's now out of service, so you don't have to complain about that. So yeah, and indeed we did have some donations, but you'll see them in the August donation video coming soon. But yeah, anyway, just a quick little check out of some LED globes, a bit of padding filler for my channel, and it was another excuse to go around and visit Tinkerman Mick and watch him do some strange things with phones. Alright, we'll catch us again in the next video. There's some big doozies coming. I've got a lot of footage for that, but I'm still waiting on parts to finish those videos. So we'll see you all in the next big video, I hope. Alright, catch you.